Hey guys, today we're going to be working on stoichiometry problems. We did the notes yesterday, and so today is just practice. And this is titled Teacher-Led Practice because I'm going to be working through all of these problems and going over why I'm doing what we're doing. Okay, so please, please be patient. Please stay with me. If we can make it through today, then it's just going to make each day easier after this. Okay, to start off, at the top here, I have the 3 different definitions of a mole, okay? So we're still doing moles. If you didn't do too hot on the mole test or you still have hesitations on it, make sure you're asking us, okay? I know it's not ideal to have to ask us questions, all right? And we might not be able to get back to you right away, but let us know so we can go back and help you, okay? Because you have to know moles in order to do this unit and the next unit, all right? So the first thing you need, sorry, now we're going to stoichiometry. The first thing you need to work on stoichiometry problems is a balanced equation. This is the equation that we're going to be using today. So everything that we're doing, we're going to be referencing this right here. Okay. Yesterday, when we were doing stoichiometry, we talked about the 3 steps to doing stoichiometry. Okay, the first one was convert to moles. The second one was to use the mole ratio. And the third one is to convert to what you're looking for. Okay, so as we work through this worksheet today, we're going to be looking up here at the equation and the rules to help us solve each problem. Okay, so you notice that when we look at these, they look very similar to working mole problems. It's like 8 moles of oxygen is equal to blank moles of water. What makes this different than the moles unit that we just covered is the elements are different. Okay, here we're talking about oxygen, here we're talking about water. All right, so again, this is like talking in the language of English. This is like talking the language of Spanish, 2 completely different languages. Okay, so we're going to start each train track with what we're given. So we're given 8.0 moles of oxygen. And then it's asking us to convert it to moles of water. So when I look at the steps, the first step says to convert to moles. But if I look at the problem, it's already in moles. Okay, so here, step 1 is already done. It's already converted it to moles. So that means I can go straight to the mole ratio. All right, remember the mole ratio is like my translator. It gets me, it's the person who knows English and Spanish and can translate to both people in the conversation. Okay, so for the mole ratio, if we have oxygen right here, then we're going to have moles of oxygen on bottom because whatever on top of one track is on bottom of the next track. All right, so this is my given. We were given oxygen. Now we're looking for moles of water, or we're looking for water. So we're going to be having moles of water on top. Okay, so that's what I mean by looking for is whatever on the right side of the question and given's whatever on the left side. Okay, when the question's written like this. All right, and for the mole ratio, this is when we use the balanced equation. Okay, so when we find oxygen, there's a 5 in front of it. So I'm going to say 5 moles of O2. Then we're going to look for water. And what's in front of water? A 2. So we're going to put 2 in front of water. All right. So again, this is my mole ratio. This is going from talking about oxygen and switching the conversation to talking about water. All right. The third step is to convert to what you're looking for. What's this asking to find? It's asking us to find moles of water. And what is this right here? This says moles of water. I don't have to do the third step because right now when I do my answer, it would give me my answer in moles of water. Whatever in the top right of your last track should be whatever unit you're trying to get to. Okay, so for this case, I only really needed to do step 2, so I could go from talking about oxygen to talking about water. When we put this in the calculator, remember, if a number is on top, we multiply, and if it's on bottom, we divide. So the way that we would put this in the calculator would look like 8 times 2 divided by 5. Okay, so go ahead and do that. All right, 8 times 2 is 16 divided by 5 gives me 3.2 moles. Okay. So let's look at the next question. All right, we have 2.53 times 10 to the 24th molecules of dicarbon dihydride, C2H2, and it's wanting to know how many moles of carbon dioxide or CO2 that is. Okay, so first thing we have to do is convert to moles. So we start with what we're given, which is 2.53, and I'm going to say E24 because that's how I'm going to put it in the calculator. Sorry, that 2 is really small. And this is molecules, which is abbreviated with MLC, of C2H2. All right, so if I'm converting this to moles, all right, I have molecules right here of C2H2, then I have to have molecules of C2H2 diagonal. Again, remember, if it's on top of the first track, or if it's on top of one track, it goes to the bottom of the next track every time. Okay. Since we're dealing with molecules, if I look up at the top, the definition that goes with molecules is using Avogadro's number. So that's what number I'm going to put right here, 6.02 E23. Just kind of ran out of space there. And that's equal to 1 mole. So I'm going to write 1 mole C2H2. Okay, so this is step 1. We've converted it to moles. Step 2 is the mole ratio. So now I'm going to go from talking about C2H2 to talking about CO2. Remember, we were given C2H2 because that's what we started with. So that means I'm going to have moles of C2H2 on the bottom. And that makes sense because I have moles of C2H2 on top here, so it has to go on bottom of the next track. And I'm looking for carbon dioxide, so I'm going to have moles of CO2 on top here. So now when we look at our equation, we have 2 C2H2. So I'm going to put a 2 right there. All right, and for CO2, what number is in front of CO2? 4. So I'm going to write a 4 right there. Okay. When I look back at my rules, step 3 is to convert to what you're looking for. This question is asking us to find the moles of CO2. And what is this last unit here? It's moles of CO2 also. So I don't have to do a step 3, okay? Anytime we're working on stoichiometry problems and it's asking you to find moles, you can stop after step number 2. Okay, but if you're doing stoichiometry, you're gonna do step number 2 every time, no matter what. Rule 1 and rule 3 just depends on what the question's asking. Okay, so let's see how we would write this in the calculator. All right, we would say 2.53 E24. Okay, and then this number's on bottom. What do we do if it's on bottom? We're going to divide. So 6.02 E23. And then what do we do if a number's on top? We multiply. So times 4, and then we divide if it's on bottom, divided by 2. Something I forgot to mention on number 1 up here was, remember when we're going through the train tracks, when we're getting ready to put in the calculator, you start on the left side and work your way to the right side, okay? I go left to right, top to bottom, just like reading a book. That's what we would put in the calculator here, okay? If you don't have the ability or the know-how to do E on your calculator, it's okay to put in parentheses 2.53 times 10 to the 24th power, but just make sure you put it in parentheses so the calculator treats that like one number, okay? When you put this in the calculator, the answer you should get is 8.41. Okay, so go ahead and pause the video, put this in the calculator, and make sure you get 8.41. I'm not going to be super picky on rounding as long as you're getting this stuff right, or the answer's really darn sticking close. So like if you said 8.4, that's fine. Okay. Let's see. All right, so hopefully you checked your answer and you got the same thing I did. If not, talk to us, because it's something with the calculator that's making you get it wrong, and we want to make sure you get it right. Okay, so for number 3, we have 325 grams of oxygen, and it's wanting to know how many grams of water we have. Okay, so now we're going from oxygen to water, so that's how we know it's stoichiometry, because it's two different things. So we're going to follow the rules. Okay, step 1, convert it to moles. All right, so this is in grams, so I need to convert it to moles. All right, so we're going to have grams of oxygen on the bottom. Let's look at the definitions. Okay, it says grams. We're going to be getting the number from the periodic table. Okay, and then that'll be equal to 1 mole. So we're going to have 1 mole on top, 1 mole of oxygen on top. And then we're going to look at the periodic table. We're going to look at the atomic mass for oxygen, and it should be 15.999. And there's 2 oxygens, so we're going to multiply 15.999 by 2. And that gives us 31.998 grams of oxygen for every 1 mole. Okay, so this is step 1. We've converted it to moles. Step 2 is to use the mole ratio. So again, before I even put numbers, I make sure I have stuff in the right place. If I have moles of oxygen on top here, then I have to have moles of oxygen on bottom here. And then it's asking me for water, so I'm going to have moles of water on top. When I look at my equation, it's 2 moles of water for every 5 moles of oxygen. Okay, so this is my mole ratio. And now here, I do need to go the third step, because convert to what you're looking for. I'm looking for grams. If I were to stop here and get my answer would only be in moles of water. So now I need to add this extra track. Okay, so if we have moles of water here, then that means the bottom of the next track, we're going to have moles of water again. But this time it's just going to be 1 mole of water, because the definition says 1 mole of water. If we're looking for grams, again, it's from the periodic table. Okay, so we're going to have to do 2 times hydrogen's mass plus oxygen. All right, that's kind of hard to read. 2 times hydrogen plus oxygen. All right, hydrogen is 1.008 times 2 plus 15.999, and you should be getting 18.015 grams of water. Okay, so to recap what we did, we converted it to moles, or we converted what we were given to moles. Then we use our mole ratio so we could go from talking about oxygen to talking about water. And then we used water's mass to convert it to grams for water for our final answer. All right, so when we put this in the calculator, it would look like 325 divided by, oops, sorry, 325.8. I realized that I forgot to write the 0.8. 0.8 divided by 31.998 because it's on bottom. I'm going left to right, top to bottom, so then times 2 divided by 5. And then this is on top, so we're going to be multiplying it by 18.015. Okay. So go ahead and put this in the calculator. And you should get around 73.37. You could have said 73.4 or just 73. As long as you're getting around this area, then you are on the right track. Okay, if you're at this point, if you're feeling okay about this, then go ahead and see how far you can get on number 4, see how far you can get on number 5, and then keep watching the video. I'm going to keep working through the problems. All right, so number 4, we have 8.38 moles of carbon dioxide. Right, step 1's convert to moles. But this is, you're right, it's already in moles. So that means I can go straight to step number 2. What's step number 2 again? Mole ratio. Okay, so if we have moles of CO2 on top, that means it has to go on bottom of the next track. And what are we looking for here? O2. So we're going to have moles of O2 on the top. We're going to come back to our equation. All right, and so our equation says for every 4 moles of CO2, we're going to have 5 moles of oxygen. Okay, so that's what I have written here. 4 moles of CO2 for 5 moles of oxygen. All right. And then, so that's step number 2, check. Step number 3, convert to what you need. We need liters of oxygen. So when I come up here and I look at my 3 definitions of a mole, atoms or molecules, grams, liters. Okay, I need the definition that says liters. And what number goes with that? 22.4. So I'm going to say 22.4 liters of oxygen for every 1 mole of oxygen. Okay. So for this one, I only needed steps 2 and 3 because the problem was already given to me in moles. So when I put it in the calculator, I start at the left, work my way right, go top to bottom at each step. So for the calculator, should say 8.38 moles of CO2. Oh, sorry, you don't have to put moles of CO2 in your calculator. You just need the numbers. So times 5 divided by 4 times 22.4. All right, so go ahead and put that in your calculator. And if you do this right, you should be getting about 235 liters of oxygen. All right, hopefully we're feeling pretty good so far. If you want to jump into number 5 on your own, do it. Okay. Here's number 5. So we have 2.3 times 10 to the 23rd, so E23 molecules of oxygen. and we're trying to find liters of carbon dioxide. So first step is going to be converted to moles because it's not in moles, right? So what mole definition are we going to be using here? We're going to be using the one with Avogadro's number, okay, because that's the one that goes with molecules. So 6.02 E23 molecules of O2 for every 1 mole of oxygen. All right, so we've converted it to moles. What's after that? Yeah, should be the mole ratio. So go ahead and pause the video, try doing the mole ratio on your own, see how you do. All right, so for this mole ratio, it should be 4 moles of CO2 for 5 moles of oxygen. All right, and we're not looking for moles, so we need to do step 3. Step 3 is asking us for liters. So it's just like the step before because liters definition stays the same. Doesn't matter what the unit is. Okay, so 22.4 liters of CO2 for every 1 mole of CO2. All right, and when we put this in the calculator, if you want to go ahead and just put it in the calculator, do it. See if you get the same answer. I'm still going to write out what you should write for the calculator though. 2.3 E23 divided by 6.02 E23 times 4 divided by 5 times 22.4. Okay, when you put this in the calculator, you should get 6.8. If you're not getting that, then try something again. You more than likely messed up on one of these first 2 steps. Okay, now for today, we did all problems using one equation. You have to have an equation in order to do stoichiometry, okay? Because each equation is its own translating step, okay? Oxygen reacts differently to C2H2 than it does to other elements, so the balancing is different, okay? So make sure that you have an equation for each problem, all right? We'll keep working on this through the rest of the week. We'll teach a little bit and then we'll let you try it on your own, okay? But I got a feeling by Friday, you guys are going to be feeling pretty confident in this, all right? Even if you're not there today, by Friday, I bet you feel better, right? I hope you guys have a good day. Thanks for listening.